Alright, hey guys, in this video we're going to be doing 1C.2, and we should be able to simplify radicals by identifying a perfect square as a factor of a radicand. Some two vocabularies is, well, what is a perfect square? A perfect square is a number made by squaring a whole number. Right, so a perfect square could be any number multiplied by itself, right, 2 times. So example can be 3 squared. Well, 3 times 3 is 9. So 9 is a perfect square. 5 squared. That means 5 times 5. So 25 is a perfect square. Ooh, excuse me. The next vocab word is the product property of square roots. So this one, kind of a long definition, but I'll kind of give you an example of it right below it. So it's for any two numbers the square root of the product is equal to the product of each square root. I do apologize for my board being so kind of sloppy, it's hard to see. So again, what it says is for any two numbers, the square root of the product is equal to the product of each square root. So what does that mean? Well, if they have the same root number, so for example, if I have the square root and I have a times b underneath my radical, what I can do is I can separate them into the square root of a times the square root of b. Right? Just likewise, if they have the same root number, I can combine them later if I need to be under one radical. Or with some numbers, an example like 4 times 25. Right? Each of these are perfect squares. I can separate these to become the square root of 4 times the square root of 25. Right? I can separate them. So that's the product property of square roots. Now, looking at the bottom, I think it's best to kind of have these next couple of examples of perfect squares so that hopefully we get to use to seeing these, we can recognize them faster when solving some examples. So, fill these in with me. 1 squared literally means 1 times 1, right? 1 times 1 is 1. Next one, 2 squared means 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared is 81. 10 squared, 100. Remember that exponent tells you how many times to multiply the base. So 11 squared is 11 times 11. 121, 12 squared, 12 times 12, 144, right? Keep going on and so forth. 13 squared, 169, 14 squared, 196, and 15 squared is 225. So yes, you'll always have your calculator available for you, but it's always best to kind of know at least 1 through 15 perfect squares because it's going to make it a lot easier when we start solving these. Alright, so now that we looked at the perfect squares for 1 through 15, now would be a good time to ask your teacher for the multiplication table, because we're going to be using that to help us with this section and the rest of Target C. So, I'm actually going to skip example 1 for right now. So looking at example 2, I see that I have the square root of 48. Now, the idea is I want to find numbers that multiply to 48. But I also want to check to see if any of those numbers are perfect squares that we have listed right above. So I'm going to pull up my multiplication table. Remember, I'm doing example 2, so I'm looking for the square root of 48. So that's the number I'm going to be looking on my multiplication chart. So looking on my multiplication chart, I want to find all the numbers that multiply to 48. So I'm going to highlight every 48 that I see. So I see a 48 right here. I see a 48 right here, 12 times 4. I see a 48 at 8 times 6. I see a 48 at 6 times 8. A 48 at 4 times 12. And again here at 3 times 16. So when you find those 48s, you want to look at the numbers that multiply to get that 48. So looking at our first 48 that I found, I see that I'm multiplying 16 times 3. Now going back to our perfect squares, do we have a 16 or a 3 as a perfect square? Yes, we do. We do have that perfect 16, which is 4 squared. So that's how I know that that's a good choice to break down my 48. So I'm going to go ahead and scroll back up here. Since we found those two factors, again, I found that nice perfect square, which would be 16 times 3. Now I'm going to use that product property of square roots that says when it's under the same radical, I can break them apart. Right? Square root of 16 times the square root of 3. We now know the square root of 16 is 4, using my little, helpers up right above. And don't forget my square root of 3. And cannot break down the square root of 3 anymore, so that is actually my final answer. 4 times the square root of 3. Looking now at example 3, I see that I have the square root of 49. So the best thing is check those numbers of 1 squared all the way to 15 squared. See if I can find a 49 that might already be a perfect square, which it is, right? I see that 49 right there. Oops. When I am squaring 7. So now that gives me my answer right away, right? Square root of 49 is 7. Right? I don't even have to look at my multiplication chart because it's actually already given to me. Next example, I see I have 7 times the square root of 75. So when you have that extra coefficient out in the front, I don't actually have to do anything with him. He just gets brought down for the ride. And I want to look at my multiplication table to see if I can break up that 75 to have a nice perfect square. So if I check the numbers above, I do not see 75 there. So that's why I'm going to go to my multiplication chart. I'm going to see if I have any 75s. I see one right here. Right, 15 times 5. Neither of those are perfect squares. I see one right here. 15 times 5 again. Perfect square. And I do not see a perfect square on my chart, right? It's only a 20 by 20. So in case that ever happens, what you can do then is go back to our perfect square list. And you look at those perfect squares. If I'm trying to break up the number 75, what would be the best thing to do then is to look at all these perfect squares and divide them and see which one 75 goes into or can be divided by nicely. If I look at 1, is 75 divided by 1? Still 75, that doesn't really help me. Can 75 be divided by 4? Well, let's look at our calculator. Alright, so looking at our calculator, I'm trying to see if any of these numbers divide 75. So next one would be to see is, does 75, is it divisible by 4? No, it's not. It gives us a fraction. Move on to the next number. Is 75 divisible by 9? No, it's not. Is 75 divisible by 16? No, it's not. Is 75 divisible by 36? Oop, I forgot a number over here. Is 75 divisible by, I believe that's 25, right? 5 squared. 75 divisible by 25. Yes. So right there I see that 75 can be divisible by 5. That already tells us then, well, that's our perfect square that I'm going to use to break up the number 75. So I can write now, underneath my radical sign, 25 times 3, right? So that was the whole point of trying to find that perfect square, right? 25, I see that perfect square right above. So now I can use that property where I can split up my radicals. Again, that coefficient just gets brought down. I could change this to the square root of 25 times the square root of 3. And now I can take the perfect square of 25. We know that is 5. So now I have 7 times 5. Again, because the square root of 25 is 5. Can't forget my radical of a 3. And now I just need to simplify. So I have those two coefficients up there, so I'm going to go ahead and multiply those together. So 7 times 5 is 35. Don't forget my square root of 3, and that is my final answer. All right, going to draw my line here. Likewise, example number 5, I have the coefficient of a 12 times the square root of 8. That coefficient, nothing happens to it. I bring him down, and I'm going to try to find nice numbers that can break up 8. If I have to look above, right, are there any numbers that I see? Is 8 a perfect number? No. But can I see any number that 8 is divisible by? Or again, go back to my multiplication chart. Hopefully we can know that 8 is divisible by 4. And we can break 8 up to be 4 times 2. Again, the reason why I'm using 4 is because 4 is right above. It is a perfect square. And that's the whole idea. We want to find those perfect squares. So breaking up my radical then, square root of 4 times the square root of 2. Bring that coefficient of a 12 down. The square root of 4 is 2 times the square root of 2. That guy also gets brought down. And now I can just simplify. So 12 times 2 is 24 times the square root of 2, which is my final answer. All right, next one I have example 6, where I have 4 times the square root of 81. So I know that coefficient of a 4 is just going to get brought down. And I want to break up the square root of 81. So looking above, always check to see if I have a perfect square. And we do see that the square root of 81 is a perfect square because 9 squared is 81. So I'm going to break that up, right? Doesn't really change. I can break up the square root of 81 because I can right away take the square root of 81, which is 9. So 4 times 9. Those are nice coefficients. We can multiply those together to give us an answer of 36. All right, now going back to example number 1. The reason why I wanted to wait is because obviously 72 is not on our factor chart. It doesn't fit. It's not there. We can't find any of those perfect squares. So we're going to do exactly what we did in example 4, where we're going to divide 72 by these perfect squares. All right, so I'm going to pull up my calculator one more time. All right, so I have my calculator here. And I'm going to check, again, my perfect factors. So I'm trying to break up 72. So I'm going to say 72 divided by 4. That's divisible. 18. But let's try to find a bigger number. See if we can find a bigger perfect square. So if 72 divided by 9. That's also a nice perfect square. See if there's anything bigger. Let's say 72 divided by 16. Nope, that's a fraction. 72 divided by 25. That's a fraction. 72 divided by 36. That's a nice number. 72 divided by 49. Nope, that's a fraction. 72 divided by 64. Nope, that's a fraction. And notice the next number I would check is 81. 81 is bigger than 72. So that's how you know there's no other perfect square that could possibly break up 72 because the number's already bigger. So the biggest perfect square that we could find within 72 is actually 36. So that's the perfect square that we are going to use. And breaking this up then, the square root of 72 can be broken down to nice perfect square of a 36 times 2. Separate my radical. Square root of 36 times the square root of 2. 36 again within our perfect square, so the square root of 36 is 6. Don't forget my square root of 2, and that is my final answer. Alright, so again, use your multiplication table. You can use the perfect squares, and then you can go ahead and move on to activity 1C.2.